So I just a moment. So am I audible to you all?
Yes, sir.
Okay. So first I do something here. I remove that. Uh, First I hide my video panel. And in this workshop, we do the data analytics and machine learning with R. And I will explain you the curriculum of this 5 days workshop. There are many workshops with R, R1, R2, R3, R4. This is the R foundation. And after R foundation, we our next workshop is our intermediate, then our advanced one, and then our advanced two. And we cover up to the machine learning algorithm with R. So let me share a few things with you that we have so many tools which we use in the data analytics and in machine learning. Like the Python we use in the data analytics and machine learning, R we use, advanced Excel we use for doing our Hadoop we use for the big data, and Spark also we use for the big data in real time. MySQL we use for the database, and these all things. SPSS is also a software which is developed by the IBM, or it is a licensed. SPSS is licensed, and where we could perform some statistical analysis. SAS is also for our statistical analysis. In the machine learning, we could also perform little bit in the SAS. There are few tools like Tableau and the Power BI, which is related to data visualization. So data analytics or the data science is not R, is not Python. These are the tools which help us to do this sort of uh, activity or the programming in a quick way, in a easy way. So there are various types of analysis, like the descriptive analysis, the inferential analysis, the predictive analysis, and the perspective analysis. So we could do this all sort of analysis with R. Here I have written few analysis, like the univariate analysis and the data visualization is there, and the data manipulation, the correlation analysis, hypothesis testing, a priori neural network, k-means, and there's so many things we could do with R. And there are some specific, the sentiment analysis, we use some of the algorithm, and the churning analysis there for, and the meta analysis is also there, pandemic analysis, market basket analysis, customer segment analysis, this sort of different projects we could perform through the R. Now, the core of data science, data analytics, machine learning, artificial intelligence is statistics. Because wherever the data, there is statistics. So if we see the generic definition of the statistics, and I am here comparing the statistics, data analytics, and the data science. So look at here, if we see the generic definition of the statistics is a science and art of collecting, classifying, computing, analyzing, interpreting, and presentation of data and its insights. So we have seen that it is a science and art. First, we collect the data from the various sources through the internet or through the our mechanism, the business process, whatever we have, and through the questionnaires and so many things, Google Forms, whatever you have, you collect the data. Then you classify the data. There is a various classifications of the data we will learn here. And then computation means we compute the statistics, whatever the data we are getting, and then whatever we compute there in the statistics is called the statistics, like the mean, mode, median, standard deviation. These are all called the statistics. And after getting a result through the computation, we analyze it. Analyzing is a brain process, or the mind process, you could say that is here. And we analyze it, and after analyzing we interpret that. Okay. And presentation of data and its insights, finally we present the results or the data, whatever insights of the data, whatever we have, in a different format, like the tabular form, in the text form, or the statement, or in the figure and the graphs also. Okay, so this is a complete definition of statistics. But here you see, I have written that the statistics is a science and art both. What does it mean? So here I will give you one example, which you will see on the next slide. We have to find out the mean of this small data. So I would like if you calculate mean for me for this data. Please you calculate the mean of this data and write in the chat board what would be the mean. These are the values 2, 5, 8, 10, 7. Use the calculator whatever you want and calculate the mean of this. Vijay, correct. You are writing 6.4. Kirti Tyagi is writing 6.4. Dhansari is 6.4. 6.4. 6.4. Yes. So Bangi is also writing 6.4. Dasara is 6.4. Hassan 6.4. Okay. So as you see in the chat board, all of us are getting the same mean. Okay. It doesn't mean that the person who is having the more experience in the statistics will get the better mean than you. If I have the more experience than you, then it doesn't mean that my mean would be better than your mean. So it is a science. It will give us the uniform result. Okay. Whoever calculate this and won't do any calculation mistake, then we'll get the same mean. Okay. So it is a science because there is some basic formula which is working behind that process. So like in the chemistry, if you see, if we mix the acid and base, what we will get? We will get the salt and water. Everybody will get the salt and water. Nobody could get the alcohol out of that. So it is a science. So here the statistics is a science because we are using some formula, and on the basis of those formulae we are getting some statistics, and the statistics will all around the same. Okay, whoever will calculate it will get the same value. So it is a science therefore. Second thing I have written that it is science as well as art also. So why it is an art? So I will explain you that also. We take one example in the next example, next slide. This is a glass of water. So how do you interpret this glass of water? Can you write on the chat box? How do you interpret it? Yes. This is the glass of water. How do you interpret it? So as I see that some of you are telling that it is half filled with water. And some is telling us half empty. And some is telling it is glass is filled with air. Half of the glass is filled with air. So the correct interpretation, whenever you see, when you get the result in a statistics, there is something behind the value. And that we have to cover it out. Whenever you are able to cover it out, the thing which is behind the value, you may be a good data analyst. So here the correct interpretation of this would be, some of you have already written that, I appreciate it, that this glass is full half with water and half with air. Got it? So this is the correct interpretation. The something is hidden. There is a air, but we could not see it. Or there is a water, we could see it. So that's why the interpretation is very, very important. It requires some experience. It requires some experience. So whenever the you have a requirement to experience, then it is an art. If you want to learn some music, and if you want to learn how to play the violin, so you require some practice with violin, then you would be able to play the violin. Similar way, when we have to do some sort of interpretation out of the result, then there is a requirement of some experience. Through the experience, you could get the skill of the interpretation. So that's why it is an art. Now, we go back to our previous slide. So we understand what is statistics. Now we see what is data analytics. So it is a process. It is not a science, nor a science, neither, and not an art also. So data analytics analysis is a process of inspecting. First, we inspect the data and clean the data, then transform the data as per our requirement in rows and columns, and modeling data with the goal of discovering useful information, informing conclusions, and supporting decision making. So this is a process. So how we inspect the data, because if we have a millions of rows in the data and hundreds of columns in the data, then how we could inspect the data? So we have a various process by which we could inspect the data. And we see what are the gangs, so what are the residuals, what are the things which are useless for us in the analysis. We clean the data and then we transform the data as per our requirement. And then we finally analyze the data or the modeling the data. Okay, so does that make sense to everyone? What is data analysis? Data analysis is a process and the statistics is a science and art. Okay, this process we could do with any of the tools which are available, like the R and Python, SAS, SPSS. There are many tools. Any one of the tools we could use to do this all sort of things, like the inspecting, cleansing, transforming. Now the next thing is the data science. Data science is an umbrella term that encompasses data analytics, data mining, machine learning, several other related disciplines. So here the everything comes under this. The data analytics also, data mining is also there, the machine learning, and the several other related discipline, data wrangling, and this all comes there. Data science is an interdisciplinary field that uses scientific methods, processes, algorithm, and system to extract knowledge and insights from many structured or unstructured data. Data science is related to data mining, machine learning, and the big data also. So I think these definitions, and you understand what is the statistics, what is the data analytics, and what is the data science. Now, at the last you see, I have written something that is the what is first statistics. So I have already explained what is statistics. Statistics is the whatever we compute, the mean, mode, median, standard deviation, variance, everything is called statistics. So what is first statistics basically? I would like to ask you. Can you write on the chat board? What is first statistics? Yes. Yes. Average. Lakshminder is writing average is first statistics. Average is statistics, correct? Aplori is writing the mean. Yes. Animals, there are 25 participants in this session. Only 2 has given me the response. Yes. Numbers, mean mode, median. Median mode. These are all statistics, but these are all not the first statistics. Frequency is in the data. Okay. Proportions, correct. Khadija, you are right that the proportion is correct here. Your response is right. Abid Khan. Now, I will give one hint that you could understand better way. That if you have a column like gender, and we have two categories here. One is male, another is female. And you know that we have 25 participants here in total. And hypothetically, I am writing that there are 4 out of 25, there are 5 is female and 20 is male. So this is a frequency basically. It is the counting only. It is inside the statistics we do it. It is the group by. By grouping the male, we are getting the how many times male are there, 20 times. Tally, we could say that. But if I say that there are 20 males in this workshop, is it correct? Can you analyze something out of that? Are you getting? If I just say that 20 male participants were in the today's workshop, so it is a complete information you are providing to someone. Yes, it is not a complete information, because whenever you say we have the 20 male participants in the workshop, means you have to mention how many were there total. You have to tell in this way, out of 25, 20 males participant were there in workshop. Okay, that is the correct. In spite of that, if you write the percent, you convert, it is a total is 25, and you convert this 20 in a percentage. So you will get, I will write in this way, 20 over 25 into 100. So we get the 80%, and here 5 over 25 into 100 is equal to 20%. So if you say that there were 80% male participants in the workshop, so it is a complete information now. What do you say? It is complete. So percentage is what? Percentage is nothing. When you multiply the proportion with 100%, you will get the percentage. Does that make sense to everyone? So what you are using, we are using the proportion. Ratio, correct. Ratio and proportion. So this proportion is nothing. It is basically a probability. Got? What is it? Probability. Probability means favorable outcome over total outcome. Outcomes over total. So what we are doing here, the favorable outcome over total outcomes. Got it? Does that make sense to everyone? So the first statistics is what? It is the probability. Got it? Does that make sense to everyone? From where the statistics starts. Okay? And later on, you will use the mean, mode, median, everything. And I say that the last statistics is also probability. Is also probability in any sort of analysis. In the descriptive analysis, we start the statistics through the descriptive, and we go to inferential analysis. In the inferential analysis, we test the hypothesis. Hypothesis testing. In the hypothesis testing, we perform various tests like the t-test, g-test, chi-square test, ANOVA, so many tests. And we conclude with the test value, and finally we conclude with the p-value. P-value is what? It is a probability again. Suppose you are testing a hypothesis at the confidence level. %95. It means your level of significance. What would be the level of significance? Can somebody tell me? If we have a 95% confidence level, then what would be the level of significance? 0.05, correct. It means 5%. That is the 0.05, correct? So Bangi. So the 5% is our level of significance. We could say the 0.05 also. So the value, when we test the hypothesis and we get some p-value, if our p-value, is greater than 0.05, then what will happen? Our null hypothesis will accept or reject. Suppose you have got the p-value 0.72, which is more than 0.05. Frank, you are right. We will accept the null hypothesis because the p-value is greater than that, 0.05. So we will accept the null hypothesis and reject the alternate hypothesis. Okay. It means there is no significant difference in whatever you have. Okay. Blah, blah. And if your p-value is 0.03, which is less than 0.05, it means our null hypothesis will reject. Understand? So the what criteria we use for acceptance or rejection of the hypothesis test? We use the p-value, which is nothing, it is the probability. So the inferential analysis ends with the probability. Does that make sense to everyone? Where does it end? With probability. You conclude with the probability, your test. Are you agree with me? Yes. Okay. This is about the inferential analysis part. If I talk about the predictive analysis part, the predictive analysis part, we use the machine learning model. And I will explain something in the machine learning and the artificial intelligence perspective. That is the prospective analysis also. This one is the predictive, this is the perspective. So I will talk about the chatbot. Everybody knows about the chatbot. Now it is coming with the mobile application along with the banking mobile application. You will see there is the chatbot. Most of the banking applications we are getting it. In the websites also we are getting the chatbot nowadays. This chatbot is taking the job of BPO. Okay. So in the chatbot, I will explain you. In chatbot, there are two models in one chatbot. First model is user interface model. And second is dialogue management model. The user interface model, what does it do? Because if you have to make some query in a chatbot, you want some inquiry in the chatbot, then I think the Lakshminder will write in some other way, and I will write in some other way, and Abid will write in some other way, but we are all inquiring the same thing. Are we agree with me or not? The intentions are same, but the syntax, the sentence or the statement are different. Okay. So what does this user interface model do? We apply the NLP. You have heard about the NLP? Natural language processing. Natural language processing. I give you a brief idea about this. It divides the sentence in a word form and a different word. whatever the words we have used, and then it remove the white noise, or what we say, the parentheses and is, are, the, what are the punctuations, what are the articles we are using there, what are the conjunctions are we are using there. It will remove those are, and there would be now some real words for what we call, like hungry, some word. And so this sort of words remain only with it, which has some meaning. Okay, so some verbs and nouns would be there. Okay, and it will remove the conjunction and preposition and these all things it will keep. And as per this, we have already fit few intent that are called the intention. So that is called the intent in the chatbot language. And there is the entity also. So I will not go to the entity, I will just explain with the intent. So we have so many intents. Intent is for the information intent. We have the complaint intent. We have the request intent. And then we have the various intent. I am writing only few one. So through this statement, the user interface model, we see the what intent are there. So there is an intent which is regarding with respect to inform class. It will see what are the intent with the inform class. So it will see the probability of all intent. Suppose the inform is getting the probability of 0.62 and the complaint is getting 0.54 and this is getting 0.3. So which has the highest probability of this statement intention? So the 0.62, so it will just keep it out, the inform intention, and it will transfer this intention to dialog management model. Please you write something on the information and the entity, the what sort of information you are demanding, that is the entity. I will not go to that part here in detail. So as per that, this dialog management model will respond to your question. Does that make sense to everyone? Yes. So what criteria we have chosen to ascertain the intent? So we have used the probability here again. Okay. What we have used here? Probability. And as per the probability, we have selected the particular intent. Got it? So the end of the predictive analysis or the artificial intelligence is also with the probability. Got it? So the whole statistics, the core of the statistics, I say, is probability. Understand? And the core of the data science or the data analytics is statistics. And the core of statistics is probability. So this is very, very essential and necessary to understand the probability in a deep way. Got it? If you want to learn data science. Other statistics also we have to learn, but understand the probability deeply, in the deep way. Are you agree with me? No? Yes. We are just coming to the practical part in 5 minutes. Okay. Karma is asking the level of significance. You see, suppose we have a normal data. I just a moment. We have this normal data we have, and we have this our the total area of this curve is 1. That is the probability 0 to 1. And here is our 0.505. So here the probability we are getting less than 0.05. Here we are getting the more than 0.05. So this is our null hypothesis acceptance reason. Got it? Whenever we get the probability more than 0.05, then our null hypothesis will accept. And when we get the this value less than 0.05, then our null hypothesis will reject. Does that make sense to you? I will explain this all thing karma later on in the R2, where we study about the inferential analysis, the hypothesis testing. There I will explain you what is confidence level and how do we select this level and what is the level of significance. Okay, so if you have the 0.95 confidence level, then 0.05 is the level of significance. If you have the 0.99 confidence level, you have the 0.01 level of significance. So the complete would be 1.00. Got it? It is the confidence that it is the confidence that your null hypothesis is true. This is your confidence of the trueness of the null hypothesis. We could not be 100% confident that our hypothesis is true. Our statement is true. We should have some confidence level. Statistics could perform anything, any sort of analysis, except proving the truth. We could not analyze the truth in statistics. So, sir, why most the researchers use 5% sign? Any reason? 5% is the same thing. If I write the 5%, you will see 5% means 1 by 100. So what you will get? 0.05. What is Lakshminta? If you say the percent, 5% is the same thing, 0.05. 5% means 1 by 100. Percent, per 100. 5 into per 100. So 5 on the 5 by 100, so you will get the 0.05. Does that make sense to you, Lakshminta? Yes. Now, I will not give you the much theory. I will just give one more thing. Then we will start the practical. Practical means the theory, statistical concepts of the theory I will explain you on the whiteboard. So you could better understand the classifications of the data and these all things later on. The PPT will finish here now on this slide. Now I will tell you about the analysis. So there is a classification of analysis. If we see, the analysis refers to breaking a whole into a separate components or the compartments for individual examinations. So here I have divided in 4 components like the descriptive, inferential, predictive, and perspective. Descriptive means what is. So whatever you have in the data is called a descriptive analysis. Suppose there are 20 males in this workshop and the 5 females in this workshop. So that is a descriptive analysis. Suppose you have a class, in a particular class, the marks of mathematics, if we see in the different section, A, B, and C. In A section, there is a 61 is the average marks of the section A, 54 is the average marks of the section B, and the 35 is the average marks of the section C. So this is the descriptive analysis we are getting out of the current data, whatever we have. Okay, so I have written there what is whatever you have, or we could find out some statistics out of that. Inferential analysis, why it is? If we are comparing the mathematics marks of the two sections A and B in a certain standard, suppose the class 10, in the section A, students are getting X mean marks, the group mean marks of the section A students, and the Y mean marks is the group mean marks of the section B students. There may be little bit difference, there may be difference in the mean marks of the section A and section B. This is very uh, incident, exceptionally there may be the equal marks, but the most of the time you will see there are some difference in the mean marks of the two sections, and we see there is some difference. Whether the difference is significant or not, we use some test to find out the difference, whether this difference is significant or not. And we use some test and we find out some conclusion. And if our null hypothesis is rejected, it means there is significant difference in the marks of mathematics of the section A and section B students. So then we find out the reason why it is, why this significant difference is exist between, say, section A and section B students. Are you getting it? So why it is? It is the study of cause and effect. Got it? Inferential analysis. Why it is? Then the third one comes in existence, that is a predictive analysis. In the predictive analysis, we predict something. There are two things I would like to discuss with you. I would like to know your opinion about that. One thing is the forecasting. Second thing is the prediction. So what is the difference between forecast and prediction? Yes. Can someone explain it? You could unmute yourself if you want to speak. Yes. What is the difference between forecast and prediction? You could also write on the chatbot, or you could unmute yourself and speak. Yes. Forecasting, you know that there is some forecast or there is a prediction. What is the difference between prediction and forecast? Yes. Yes. Little loud. I want to it to be a interactive session. It
Good
should
evening,
not be
sir.
the one way. Yes.
I'm not sure, but I'm just guessing this.
Yes. Yes.
We do forecast for physical features and predict human behaviors.
Okay. Physical features and predict the human behavior. Okay. Someone else can? Yes. What is the forecasting? And what is the prediction? You are little bit very near to it. Prediction is on the basis of independent factors. and forecast is on the basis of available data. In the available data, there is maybe the independent vectors. Na? There may be independent factors. Pope is telling that the prediction based on earlier data and forecasting not with the earlier data. Okay, I show you the difference. The forecasting means you have a variable like rain, and you have the data of last 50 years of a certain region, you know, the data of the rain, and you create one time series analysis model, and as per that pattern, that trend, you predict, you forecast the next year or the current year uh, rain, how would be the rain this year. So that is a forecasting. That is a forecasting. Okay, we are not in imputing, or we are not inputting the current input inside the model. Suppose I have to create a model. uh, I have to create a model for the crop production of a certain region, and on the basis of rain. So there are two variables. This is our independent variable, and this is our dependent variable. Got it? The crop depends on rain. Got it? And we make a model for this. Yes, you are right, Abid. That is correct. That is the time series analysis again. So current year rain, suppose 2020 rain, of that region, and you have a data of last 50 years. From this last 50 years data of the crop production in the rain, you have trained one model. And in this model, you impute the rain of current year, and then you get the output of the crop production. This would be, this metric ton would be the output of crop production. So it is a prediction. It is a prediction because we are giving some input, current input we are giving to the model. Got it? So it is a prediction. But if you have the crop figures, only crop figures you are taking in considering of the last 50 years, on the basis of that pattern, you are making one trend line or whatever. We have the different time series analysis. I will explain you. It may be non-linear also. And you will explain the 2020 crop production would be this metric ton. It is a forecasting. It is not based on the current input. There is only current input, it is time. There is no other current input. The time series analysis, that is the chronological order you are getting this. So it is a forecasting. Before 5 years, weather department weather department forecast the weather. And whenever this weather department forecast the weather, tomorrow would be a sunny day, so we see there is a rainy day. And then this department shows that tomorrow is a sunny day, then there is some rain. Got it? Before 5 years. But in these 5 years, you see, the weather department, whenever predict the storm will stuck on this and this day, on this coastal area, it happens or not? What do you say? Yes, it happens or not? And we saved so many lives in the last 5 years because nowadays we have the data, current data is available through the satellite. We see we have the different sensors we applied somewhere, and we get the speed of wind, we get the so many things, whatever the data we get through the satellite of the weather. And we prepared some model and we input this data in that model, then that model predict us the thing. So the prediction is more accurate than forecasting. What do you say? What do you say? Because the few things are being affected by some other factors. Okay, nothing is independent. Even the rain is not independent itself. It also based on some other factors. The amount of rain is also depends on some things, some current variables, whatever you have. How many trees, how many forests are there as per the rain occurs in the region. Does that make sense to everyone? Okay. So while the forecasting is mostly done on a single variable, you take the share price, like, so you just see the share price, you don't see some other factors. You see the trend of the share and you invest in that way. Okay. Is it clear to all? So the prediction requires some other variables, independent variables, which are as an input we use and we get the prediction. Time series analysis is also nowadays it is going very effective because there are so many things we are involving in that time series analysis. Now we have a different model like the Remax and some other models we are using in the forecasting, where we also apply the current input along with the chronological time. And that model is called the Remax. So there are two things. We are prediction and the forecasting, we are merging together. And then we are going to we are going to predict something or the forecast something through that model. In the forecast, generally we use the one variable only, the time series analysis, mostly. In the prediction, we use some independent variable, which makes some impact on the dependent variable, the significant impact. Those variable we use as an independent. Got it, Lakshmida? So that is the I would like to explain you that the difference between. So what is machine learning? Machine learning suppose the crop production does not only affected by the rain only. Rain is one of the factor. Then we have some other factors which also impact on the crop production, like the soil quality, then seed quality, what you are using there, then sunlight is also there, then fertilizers, whatever you are using, pesticides, then irrigation. These all factors affect the crop production or not. Okay. Some are in our control. Some factors are not in our control. So it is the uncontrolled. This is also the soil in the field. You could not change it. You have a 10-acre field, then you could not change the soil of the whole field. So it is also partial control. We could say we could take the earth from some other field and we could pour there, and we could apply some fertilizers here for improving the whatever the deficiencies are there in the minerals or whatever. We could fulfill with the some sort of fertilizers. Seed quality is partially controlled level because there are many seed qualities. Might be the 12 seed qualities. The particular one as per the soil and the weather condition, the humidity and the moisture, so other variables. So as per that, you have to select that seed quality. So you have the option. The sunlight is not in our control. Fertilizers in our control. Pesticides in our control as per the disease, whatever in the your crop, you could control it. Irrigation is in our control, how to give the water to your field. So these are factors impact on the crop production. Are you agree with this? And the last few years data, or I could say hypothetically the 50 years data, you have these all variables along with the crop, and you train one model, and then model provides you the prediction of the crop for the current year is X metric ton would be the prediction of the crop this year. But there is a demand of Y metric ton for current years as per the requirement of the citizens of that region, and the export we have to export for the foreign action, for the currency which we use for the development. So there is a big gap between supply and demand. There is a big gap between supply and demand, and we want to minimize this gap. So this is the machine learning model providing us this amount of crop production, but the demand is this metric ton. So for minimizing this, we use the artificial intelligence model. So this artificial intelligence model will suggest you or recommend you as per the soil quality or everything. It will recommend you the seed, what quality of seed you have to apply in the soil, as per the soil. It will suggest you, if the soil of this quality, apply this quality seed. As per the sunlight, it will recommend you the irrigation, the frequency of irrigation. What should be the frequency of the irrigation in the field in the 5 days or in the 3 days or in the 7 days? As per the soil, it will suggest you the fertilizers, what fertilizers you have to use. And as per the whatever the disease in the plants or your crop, it will suggest you the pesticides, the best pesticides. So it is basically a recommendation it is providing you. If you apply this recommendation in your field, this gap between supply and demand will minimize. So that is artificial intelligence. So what is the difference between ML and AI? I will explain you. Both are same. ML is an infant and AI is an adult. You know that a small child will learn. We all people learn with the same algorithm uh, as we use in the machine learning. We have basic four algorithm we use in our routine life. One is the supervised learning. So the lecture what I am giving to you, the session I am taking is the supervised learning. It is your supervised learning. Unsupervised learning is what there is a hot utensil kept on a floor and a small child came and touched that utensil. The next time he will touch that utensil filled with the milk, hot milk. Yes. Will he touch it or not? The small child who is coming on, he will know. That is the unsupervised learning. Nobody has. Okay, got it? So that is the kind of algorithm we use in our machine learning also. There is a semi-supervised also. Semi-supervised, I will explain you that. You watch some video of the data science on YouTube or the Udemy. So there is a something, the some pre-recorded videos are there. So that is a semi-supervised learning. Got it? That is a semi-supervised learning. And one is a reinforcement learning. If you give a pen to a small child like this, so what he will do with this pen? Most of the child, they try to keep this in his mouth. Got it? Generally. So what you do? We warn him, we request him, or sometimes we beat him, give a clap. So that is a reinforcement learning, you know? Rectifying the error, rectifying the mistake. That is a reinforcement learning. So reinforcement learning we apply in the chatbot. Supervised learning we apply in an image classification model like the Google Lens. And the different algorithm we use in a different sort of models. So the similar way our artificial intelligence, our machine learns in the similar way with the same algorithm. And the data of this, the feed of this machine learning model is the data. So when we feed the data, it understands the patterns and everything. And after some time, it becomes AI. And then it responds you. Because if your child goes in a 10th, 11th, 12th standard, then he is able to suggest you, Dad, you don't purchase this mobile. This doesn't have the good features. You purchase this one. Now he is intellectual. He is giving you the recommendations, the suggestions. Similar way, when we create a machine learning model, it is an infant. When we give the data and data and data and data, it became adult. Now he is intellectual. He is the artificial intelligence. That is the intelligence, the artificial intelligence. Why we say he is intellectual now. So it recommend you. It is the reverse process. Does that make sense to everyone? What is the difference between ML and AI? Yes? Yes?
Yes, sir. Yes.
So this is all about the theoretical part. Now we see some concepts of the statistics on the whiteboard. Sometimes it is boring for few peoples. Are you getting this whiteboard on your screen?
Yes.
So what we cover in this 5 days workshop, first I explain you that thing. The first thing we will study about the essentials of the statistics. In the essentials of statistics, what we study, I will explain you. The various classifications of the data, various classifications of data. Then we study about the measure of central tendency. It is the little bit we will not go in the formula or the formulae. We just see the merits and demerits and the utility of this. Okay. We will not go in the formula of this thing. Measure of central tendency. Then we study about the measure of dispersion. Later on the correlation analysis. Tomorrow we finish this part. And the second is R data types. Every language has a different data types. So R is also various data types. We will study about that. Then R basic syntax. Basic syntax, how to coding. Regarding, I mean to say it is coding. Then third would be the descriptive analysis. In the descriptive analysis, we will perform on two types of analysis. One is the univariate analysis. Second is the bivariate analysis. We will do only these two things. We will not do the multivariate analysis. That will come later on the other workshop. So this is the whole we will study in our next 5 days. Understand? Everybody got it? What we are going to cover? Okay. I choose some my favorite colors here first. Then we start. let's we start. We are going to start the various classifications of the data. Uh, so we will see the various classifications of the data today. And I will explain you the first classification of the data. We have a various name, but I am using the according to work. So this is for the numeric data. Okay. We got the two sort of data. One is the numeric, one is the categorical data. So this classification is for the numeric data. So there is first one is the raw data. Second is the discrete data. And third one is the continuous data. Okay. So what is raw data? Hypothetically, suppose we have to perform a survey in various locality of a city like Mumbai. You have to perform in the Kandivali, we have to perform in the Borivali, we have to perform in Mira Road, Daisa, and the different locality. We have to choose the 100 houses, and we have to perform one survey. Suppose it is the survey of the UNICEF, and the UNICEF survey we are going to find out how many children are there in a family below 5 years. So how many children are below 5 years in a family? We want to find it out. We approach to first house and we ask how many children are there less than 5 years. So in the first house we see there is no children. Second house we see there is three children less than 5 years. Then one children, then one children, then two children, then three children, then four children, then no children, then no children. In this way we get the data of the 100 families. Got it? And when we find out the unique values, when we find out the unique value, so there are the unique values what we get there. There is a 0 children, 1 children, 2 children, 3 children, and 4 children. Because the below 5 years we have only these 5 values we are getting. Again repeating again and again. So we have 100 observations. In this 100 observations, we are getting only 5 unique values which are repeating again and again. So this sort of variable is called the discrete variable. There are very few unique values with respect to the data size. And whenever we get this discrete variable in R, the few unique values in R, we convert that variable because we get the numeric variable. Basically, this is a numeric. And we convert that numeric in a factor. We convert them in factor. Whenever we get the few unique values, we convert that variable in a factor form. Got it? Suppose we have also asked to know the weight of the children which are less than 5 years. So we get the weight like this 5 kg, 5.2 kg, 6.3 kg, 7 kg, 8.1 kg. In this way we get the weights. or not? So if we see the unique values for this, so we may get the 80 unique values out of 100. We get the 80 values. We may get the 60 values. We may get the 50 values, 45 values out of 100, 45 different values. Are you getting it? So there is no few unique values. There are many unique values. If you have the many unique values, then it would be a continuous variable. It would be a continuous variable. So we will not do anything with that. Whatever is the format of that column, we will keep it as it is. We will not convert in other form. Is it clear to all? Yes. Okay. If we have very few unique values, like we are getting, if we are asking about the children's less than 5 years, so we are getting the maximum 4 children is less than 5 years in some family. Some have the 1 children only less than 5 years, some have no children less than 5 years, some have 3 children. So we have the very few unique values in the 100 observations, 100 family you have surveyed. So it is a discrete variable. If you have not the extreme values, suppose I explain it with a column like gender. Okay, we have gender column and we have a male. First is male, second is male, third is female, fourth is male, fifth is male, sixth is female. In this way, I have the data. I take the 10 times so you could better understand. Female, 8 male, 9 male, 10th female. So you see, we have how many unique characters are there? How many categories are there? How many categories? 2 categories. There are 2 unique values. It means there are 2 unique values. Understand? Here you see, we are getting these numbers 0, 1, 2, 3, 4, 5 many times. 0 we have got few times, 1 we have got few times. So how many categories are there? If we think in that way, so there are the 5 categories 0, 1, 2, 3, 4. So these are the unique. Understand? Yes. Kirti? Got it? What does it mean by the unique? So here we have the very few unique values. Whenever you have the few unique values, the less category are there, then you convert them in a discrete, in the factor form. So that is the discrete data. When you have a unique value is more than that, like if you are asking about the weight, so there are the different weight, there are 50 gram difference also in the weight of the children. So we'll get so many unique values in the weight or not. What do you say? Less than 5 years, there is a children of 1 month, children of 8 months, children of 7 months, children of 1.5 years. So all children having the different weight as per their age. So we have so many unique values. So it is a continuous variable. Got it? Now everybody knows it. What does it mean? Understand this classification? Okay. Now we see the another classification. That is a according to nature. If we see this classification according to nature, we have nominal data, we have ordinal data, this is according to nature is also we get the numeric values or the categorical also, the both sort of the character and the numeric. And then interval data, and then the ratio data. You get this. Nominal data means wherever you have a naming, there is a nominal data, like a categorical data. You see the gender. In the gender, you see the male and female. You have some other, the color of eyes. So brown, black, blue. Got it? So this is the categorical, the naming is there. This is a nominal data. When we talk about the ordinal data, there is an order, but there is no fixed interval. Order 1, 2, 3, 4, 5. Like a Likert type scale, if I talk about Likert type scale. In the Likert type scale, we have it starts with 3 and maximum we go to 7, maybe 8, 9 also, but generally we use 3 to 7 Likert type scale. That's 3 points to 7 points. I am talking about the 5 points Likert type scale. And that is the agreeness, scale of the agreeness, you will see. I'm writing here, strongly disagree. Then disagree. Then not certain. Then agree. And finally strongly agree. And here I give some number to them. 1, 2, 3, 4, and 5. These are the order. So there is no fixed interval between 1 and 2. In the scale you see, we have the fixed interval in the centimeter, 0 centimeter to 1 centimeter, 1 centimeter to 2 centimeter, 2 to 3. We will get the same interval. But in this ordinal data, we won't get the fixed interval. So it is not a scale. It is a Likert type scale. It is not a Likert scale. Likert type scale. Likert is a scale is a different thing. Okay. Suppose I will explain you this with some example. Suppose there are 3 employees in a company on the same post, Mr. A, Mr. B, and Mr. C. And the management decide to give them some increment in their monthly salary. So management decided to give 2,000 rupees in increment in their monthly salary. And all of them, ABC, all the 3 employees are not satisfied, strongly disagree with this 2,000 rupees increment in their salary. They all strongly disagree. And then finally management decides we increase 3,000 more and it will become 5,000. So with 3,000 increase in the increment, what happens, I explain you. This is the strongly disagree, then disagree, not certain, agree, and strongly agree. What happens now, I will show you. Mr. A, with this 3000 amount, switch to strongly agree with 3000 rupees more. Now he is strongly agree with the decision of the management. But Mr. B is only switched to not certain. He is not agree, not disagree with this 3000 rupees. Mr. B. And Mr. C is only switched to here with this 3000 rupees amount. Strongly disagree to disagree. See, you see, the amount is same, the scale is, the interval is not same. Getting it? Somewhere the 3000 rupees is a scalar, it is a scalable amount. And that is a rupees. Rupees is a scale. The rupees, if I tell I am giving the 500, if I say I am giving the 1000, then 1000 is the double of 500. We know that. But here you see the 3000, what is happening here? It is the gap if 3000 from here to here. Gap of 3000 is here to here. And gap of 3000 is also from here to here. So it is not fixed interval. Does that make sense to everyone? Yes. Got it? Any doubt here?
Clear.
So now I will tell you about the some other 2 points, the interval in the ratio. So I will write here one interval. And here I write the ratio. And then I take this 2. Okay, I do not take this 2. I will write the 0. There is a difference of 0 in the interval and ratio scale. There are 2 sort of 0 we have. One is pseudo 0 and one is real 0. Pseudo means lie. It is not real. Pseudo 0 is what? If I talk about the temperature in the degree Celsius, if I say the 0 degree Celsius is temperature, what does it mean? There is no temperature. If I say the 0 degree Celsius temperature is today, it means what? There is no temperature today. What do you say? Yes. There is temperature. But I am telling the 0. If I tell you the Ramesh has got 0 marks in mathematics, then what does it mean? There is some marks. He got some marks. No marks. It is a real 0. It is a pseudo 0. There is a temperature. But the temperature which freezes the water, where the water starts to freeze, is called a 0 degree Celsius. The below 0 degree, there is also temperature. Okay. So this sort of thing is called the pseudo 0. And the 0 has a property. If you multiply a number with 0, what you will get? What output will you get? Yes, 0. And if you divide a number by 0, what output you will get? What output will you get here? Infinite. But if I multiply this 0 with some quantity, suppose it is a temperature, this is a volume. So what I get? I will get the 0 volume. Whatever the quantity, the physical I will get later on. What I will get here? May I get the 0 here? Not. It is not equal to 0 because it is not a real 0. It could not have that properties which the real 0 has. This property does not possess by this pseudo 0. It could not convert any multiplier in a 0. So what we do at that moment? You see, first you find out how many unique values are there. Suppose there is a 0 and -2 and 5 and 3 and -2 and 0 and 1. In this way, you have a very few unique values. You have the 7 unique values, you have the 8 unique values. Then you convert them in discrete. And when you convert this in discrete, it means you will convert them in factor. Then it will become the discrete. And the factor, it would be just treat like a category. And then you could perform this thing. Further analysis you will perform as per that. But if you have so many unique values, then you could not convert them in discrete. That is a continuous. In the continuous, you have to keep as it is. But there is a one way. We could make some class intervals. So we could try make -15 to -10. -10 to -5, -5 to 0, 0 to 5, 5 to 10. In this way we take. And remember one thing, the 0 must be on the upper and the lower limit somewhere. It should not be inside that. You should not write -5 to 5. So 0 is in between. So this would be a wrong process. And now you find out the mid value of this. So you add on these two and divide by 2. So it is -12.5. It is -7.5. It is -2.5. It is +2.5. It is +7.5. There is no 0 now. You will not get any 0 here in this sort of mid values. Will you get any 0 here? Yeah. What do you say? Will you get any 0 here? You won't get any 0. Now you could multiply this with any variables. No problem. So there is no 0 now. So you have to give this sort of treatment whenever you get it. Is it clear to all? So now I explain you. In interval, there is a both sort of 0, pseudo, as well as real. But in ratio, there is only real 0. So the both thing is called the scale. Okay. One thing you should remember, nominal is not a scale. Nominal is a data. Ordinal is a data. Interval is a scale and the ratio is a scale. Got it? These are a scale. These are data. This is also data. but we could say it is. Okay. Any doubt up to here? Yes. Now, last classification we see. This is the last one we are going to study. According to what? Here we have various classifications. We have a numeric data here. Integer we also say, and in the sum library we use there, it is converted in double. Numeric and double both are same. Then there is a character. Whatever we write in quotes, that is a character, like the male, female, and these all are called a character. Then there is a logical. Logical is a binary, that is the logical response, true and false. True and false, that is the logical. And there is a raw data, we will not study it, and there is the complex data, complex number, we will not study it. So we will not work on this in the data analytics. We will see only this. The character, that is for the category, numeric, logical. Okay. This data types we will study in R. Tomorrow we start with practical. Then tomorrow not. Tomorrow we have some other theoretical part. But I hope tomorrow we could change our pattern also, because tomorrow we start with practical, I think so. The later on I will when I will teach you the descriptive analysis, then I will explain you all the theoretical aspects like the mean, mode, median, standard deviation, these all things. Okay, so we may start the practical tomorrow. The some of you may came to learn the R, so they will get the benefit from the second day itself. And when we start the descriptive analysis, then I tell you about the deep statistics regarding that. So today we have understand the classifications of the data. I think it is nice, Dr. Sivali. So the survey that we used to measure by kind of the psychological traits, does that come into ratio with the interval data? In the psychology, mostly use the Likert type scale, Kirti. And I will explain you that in how to convert that Likert type scale in the Likert scale in the interval scale. There is a trick. Okay, we may convert that. So it's okay. So now, whatever the doubts you could ask me on the next day when we start the session, and I will rectify whatever you have doubts for the 2 days according to today's session. And now I will call to Mr. Mukesh. Are you
Yes,
there, sir? It's over to you, sir.
Thank you, sir. Thank you very much. It was a wonderful session today, sir. And
Yes,
thanks to all the participants who all are here. So tomorrow we are meeting 5 o'clock. All of you be on time, 5 o'clock. As I have said that tomorrow we're going to have an introduction session where we're going to, that talk about ourselves. Like, that you can tell about your name, where you work, what you do right now, from which country you are. So maybe we'll start early so that we will save time. So 5 o'clock sharp we will start. All right. Okay.
Sir,
Yeah.
sir, are you going to send the link again for the next class, or we need to go for the same link, sir?
For which class? R2?
Next class, tomorrow class.
No, it's the same link for coming 5 days.
Yes, sir.
The link will be same for 5 days.
Yes, sir.
gonna use the same link for 5 days.
Yes, sir. Thank you, sir.
All right. All right.
Yes, thank you so much.
Thank you. Thank you. So we have R2 session now, sir. We should jump
Yes,
to
sir.
that. And all the participants, those who enjoy the session today, you can just click on thumbs up or clap for sir. You have a reaction button on your screen. You can just thumbs up for sir or clap for sir. Thank you very much. Thank you, Lakshmi.
Thanks everyone. Thanks everyone.
Darshan, Vasil, Srivali, Beauty Singh, Abdul Razak. All right. So all of you, thank you very much once again. So let's meet again tomorrow and have a nice evening. Enjoy your evening. Let's connect tomorrow. So till now, bye.
Bye. Thanks you.
Thank you. Thank you.